Hello guys, today we want to start our lecture on convergence of Fourier series. So we want to see that for piecewise continuous functions, the Fourier series of a piecewise continuous functions converge to what values. So let's assume f and f prime, they are piecewise continuous functions on the interval of minus p to p. The Fourier series of f converges to fx at the point of continuity. At the point of discontinuity, the Fourier series converges to the fx plus fx minus divided by 2, where fx plus and fx minus denote the limit of f at x from the right and the left respectively. So let's solve one example to see how we can use this definition to find the value that Fourier series converge to. In this example, the function f shown below is defined on the range of minus pi to pi. What value does the Fourier series for f converge to? When x is equal to 1, when x is equal to minus 1, when x equal to 0, and when x is equal to pi. Here is our function. If x is between minus pi to 0, so it's equal to 0. In fact, in this range, so the function is equal to 0. And if x is between 0 to pi, in this range, the function is equal to 1. So we want to find, we don't want to find Fourier series of this function. We just want to know that Fourier series converge to what value at these 4 points. When x is equal to 1. At x is equal to 1, so we are in this point. So at this point, function at point x equal to 1, the function is continuous. As a result, based on definition, Fourier series approach to magnitude of function at point equal to 1. So in this case, Fourier series converge to f1, and f1 it's in the second range, so f1 is equal to 1. As a result, when x is equal to 1, Fourier series converge to Fourier converge to 1. So when x is equal to minus 1, at x equal to minus 1, again our function is continuous. As a result, Fourier series converge to f minus 1. F minus 1 is equal to 0. As a result, Fourier series converge to 0. At point x equal to 0. So based on definition, when x is between minus pi to 0, so function is 0. As a result, here I have to consider a circle. And when x is equal or greater than 0 and less than pi, so function is equal to 1. So it means that at point 0, we have a point of discontinuity. Based on definition, so it says that the Fourier series converge to fx plus fx minus divided by 2 at the point of discontinuity. So in fact, we have to find f0 plus f0 minus divided by 2. f0 plus is right limit of function at x equal to 0. So if from right, if I approach the function, so I'm here, so f0 plus is going to be 1. And f0 minus, so if I approach from here to the 0, so in fact we have f0 minus, so we can see that it's equal to 0 divided by 2. As a result, it's 1/2. So it means that when x is equal to 0, Fourier series converge to 1/2. You can see here we have the original function. Red function is fx, and blue one is the Fourier series when we consider n equal to 10. So you can see that the blue one is the Fourier series. So when x is equal to 1, we can see that the Fourier series converge to 1. We already said here. When x is equal to 1, Fourier series converge to 1. When x is equal to -1, you can see the Fourier series, the blue one, converge to 0. So it makes sense. Here we have when x is equal to -1, Fourier series converge to 0. When x is equal to 0, based on definition, we found that the Fourier series converge to 2. When x is equal to 0, so you can see that the blue plot, which is for the Fourier series, so it converges to half. In fact, here. So as a result, we could verify this result, this part, the part number 3 as well. So now we have to find the value that Fourier series converge to when x is equal to pi. So in fact, at this point, here we have pi. So how we can find this point? Can we found? At first we have to know if it's point of discontinuity or not. Yes, it is, and then we have to find the limit of function at the pi minus and pi plus. But you have to know that Fourier series is a periodic function and it repeats itself. Here in this plot I showed Fourier series for the next period. So here we have 0 to pi, here we have 2 pi, 3 pi, and so on. So you can see that the function is periodic, and the period of function is from minus pi to pi. The period of function is 2 pi. So here we have minus 2 pi and so on. So you can see that the Fourier series is a periodic function and it repeats itself. As a result, if you want to find magnitude of Fourier series at point pi, so you have to find f pi plus f pi minus divided by 2. So f pi plus means that we have to approach to pi from right hand side from here. So you can see that is 0. Plus f pi minus, so you have to approach to the pi from left hand side, so you can see that it's equal to pi, it's 1 divided by 2. As a result, it's equal to 1 over 2. So in fact, at point x equal to pi, the Fourier series converges to 1/2. So here Fourier series converge to 1/2 as well. So we could find the values that Fourier series approach in different x magnitudes.